From fingerprints to genetic prints, it changed how we catch the crooks. From 2 packs a day to 1 Band-Aid on the arm, it curbed a major craving. And from space race hostilities to gravity-free global harmony, a space station created new world peace on high. They're all inventions of the 1980s, a decade defined by high tech, in the office, in the lab, and just about everywhere. From DNA fingerprinting to the Mir space station to the internet, they're all inventions that shook the world. A new kind of fingerprint, one that can't be wiped away. It's the high-tech way to catch a crook. And none of it would have happened without a sharp-eyed British scientist at the University of Leicester. One morning in 1983, geneticist Alec Jeffreys is horrified by the headlines. A teenager has been brutally raped and murdered in a nearby village. A terrible tragedy, but there's nothing Jeffreys can do about it, or so he thinks. He's using his sharp mind to solve the mysteries of disease, not murder.
Jeffreys was the kind of guy who did not let anything go unobserved. And that is the mark of somebody who is really paying attention. Somebody's going to push back some boundaries that you haven't even thought of yet.
Jeffreys must have been born with science in his genes. He had his first microscope at the age of 8. By 22, he graduated from Oxford with a first-class honors degree in biochemistry. Now, in the mid-80s, he's found his life's work in DNA research, the chemical coding system that makes us who we are. It's still a new field, but Jeffreys and his colleagues do know a few things. 1, we share almost all of our DNA with chimpanzees. 2, only a small part of our DNA makes us human. And 3, it's just a tiny fraction of our DNA that makes us physically different from one another. But Jeffreys is sure that DNA holds even more secrets, that if he can unlock them, it could help diagnose and cure disease. At the moment, he's studying a single gene. Just one tiny piece of the long, twisted DNA strands that make up the human genome. As he looks closely at the X-ray film of the gene, he notices something odd.
In the gene, he found a small region in one of the spots that didn't code for any protein.
In other words, bits of DNA that appear to have no function. But they do have interesting repeat patterns that he's never seen before. Jeffreys realizes this could be important. He's determined to find out more.
He's a very alert guy. So he says, gee, I wonder where this came from. Are there other sequences in the genome that could match this?
That's the next big question for Jeffreys. Will he find the same strange repeat patterns in other genes? He draws blood from a lab associate and her parents to compare their DNA. At first, the results just look like a smeary mess. Time for a closer view.
Come take a look at this.
He's still not certain what to make of the results.
What do you see?
I'm not sure yet.
But gradually, he starts to see distinct patterns in the DNA of mother, father, and daughter. Then, suddenly, it hits him. he's made an astonishing discovery. The repeat patterns in one person's DNA are distinctly different from those in anyone else's, as unique as a fingerprint.
He did use this word of DNA fingerprint, and it is appropriate because just like a literal fingerprint, these are unique to any individual. So he realized that this has legal and forensic potential.
Jeffrey's discovery means there's now a new way to link suspects to a crime, and he'll soon have a chance to prove that the new science works. It's now 3 years since that first rape and murder, and suddenly the body of a second teenager is found nearby. A young man is charged with a second rape and murder after he confesses, but he won't admit to the first. By now, Jeffrey's DNA fingerprint discovery is well known.
So Jeffries is approached by the police, and they say, listen, we have someone who's confessed to the second murder, and we have his blood, and we know he's done the second murder. So all we want to do is find out if we can also indict him for the first murder.
Jeffries compares the suspect's blood with the semen from both crimes, and the results are a shock to everyone.
And he comes back to the guys and he said, well, I've got good news and bad news. The good news is it's the same murderer in both cases. The semen DNA profiles are identical. But the bad news is the guy who's confessed to this murder is not the murderer.
Now the police are even more determined. News reporters are on hand as all the local men are brought in for blood tests.
And they make a decision to go about collecting blood from every man in the community to see if they can ferret out the person who's actually committed these crimes.
The police hand the samples over to Jeffries. He tries to match the DNA results with the semen from the crime scenes, and he fails. But it isn't his science that has let him down. Turns out the real killer had found a way to rig the DNA tests.
The man who committed the crime actually convinced a friend to give a blood sample for him because he didn't want to be discovered. Months went by, and the guy who had given the blood sample for his friend was talking to somebody else at a pub and said, oh, I gave this blood sample for this other fellow, you know? And that person ultimately reported it, and they, arrested the man who was the criminal and tested him, and indeed it was a match.
DNA matching has put many criminals behind bars, but it has also freed hundreds of innocent people.
A handful of these have been on death row, so their lives have been saved.
Even Queen Elizabeth II recognized the value of Alec Jeffrey's service to science. In 1994, he was knighted. But despite all the fame, the father of DNA evidence is still working. Happiest when he's hands-on in the lab, searching for the vital clues that someone else might miss.